Okay, so this will be in the final video going over those sub-questions, and I'm going to post some screen caps of some other answer keys that I've made just so you can check some of your answers, but those answer keys do have all my work on them as well. Granted, some of that work, like this, will look somewhat messy, you know, if you don't know what I'm doing. So the videos are probably a lot more helpful than just looking at answers, but that's just an opinion, I suppose. Anyways, question number 66 gave you this data table. I copied it over here before starting because I wanted you guys to be able to see that as I go through here, because this question was more about reading a data table than it was, you know, just roguely copying down and doing questions. So, anyways, 66 is a challenging question. So the analysis of the pain reliever morphine yielded the data shown in the table. Determine the empirical formula of morphine. And here's the thing. This question seems like it's going to be harder than normal, but it's actually easier than normal. See, this percent analysis they've done is a mass analysis. See, some machines we use don't actually give us percentages. They give us the actual masses that were inside the sample. Which means that first step, taking your percent composition and making that into mass, you don't have to do that. It's already done for you. So all we've got to do is take our grams and convert them to moles, and voila, we've got a mole ratio, and you're done. So it takes your problem and actually makes it simple. So I'm just going to write everything down here so I can do some math. 17.9 grams of carbon, 1.68 grams of hydrogen, 4.225 grams of oxygen, and 1.228 grams of nitrogen. I'm going to use 2 decimal places for all of my conversions here. Grams to mole, you use molar mass, so you find these numbers on the periodic table. I prefer dimensional analysis, but you know, that's just a preference there. Mass of carbon on the periodic table is 12.01 grams per 1 mole. So this will give me moles of carbon. Mass of hydrogen on the periodic table, 1.01 grams per mole. Gives me the mole of hydrogen. Divide by the molar mass of oxygen, 16 grams per mole. Gives me the units moles of oxygen. And you know, divide by the mass of nitrogen, that's the periodic table. Gives me the moles of nitrogen. And again, yes, I realize I just wrote that different ways. But when I'm in a hurry, I prefer using this slash right here, because that just means, you know, divide by. I don't like the division symbol, but if you use it, that's whatever, that's fine. As long as I can see how you're doing your math, you're okay. But I mean, of course, I do honestly prefer dimensional analysis. And for what we're doing this coming week, dimensional analysis just can make life so much easier if you can figure out how to use it. And we've been doing it for so long that you really should be able to do dimensional analysis by now. But again, I just personally think it's easier. It's up to you guys to decide if it is. 17.9 divided by 12.01. 1.49. Remember, you don't want to round anything yet because you're going to have to divide by your smallest number of moles to get a whole number ratio. So don't do any rounding yet. I say any rounding, but there was a 0 there, so I'm keeping 2 decimal places each time. 1.68 divided by 1.01. And this is 1.663. I'm going to round to 2 decimal places because I'm just going to try and be a little bit consistent with my work. 4.225 divided by 16. I'm going to give you a decimal 0.26. That 4 I'm going to leave on here. No, I said I was going to be consistent. I'm just going to do 0.26. Be consistent. 2 decimal places. 1.228 divided by 14.01. And 0.087, around that 0.088. Okay. So the smallest number we have is this one, 0.088. So we're going to divide everything we have by 0.088. All of these values, if we divide one thing by it, we have to divide them all by it.
I wasn't going to say I was someone in a position of authority coerced you into a relationship.
There we go.
What are you doing, Mark?
I just got to get all this stuff typed into my calculator here.
Do you really think that's what I need?
I'm trying to get it so you guys can actually see the screen of what I'm typing, but 1.49 divided by 0.088.
Interests are none of your concern, Lex.
16.93. All right. I might have to round that number a bit, but I don't know yet, so I'm just going to keep looking at what I got. 0.088. 18.86. 0.26 divided by 0.088. 2.95. And of course, this is going to be 1. So from the looks of these numbers, it looks like everything is close enough here to just round these to the nearest whole number. None of these are perfect fractions. 2.95 is basically 3, so it's pretty safe to round that to 3. 16.93 is basically 17, so it's pretty safe to round that to 17. This number seems a little bit off, but do remember, I did round everything I did over here, so my numbers won't be perfect because I rounded to 2 decimal places. And this is larger than the largest perfect fraction, 0.75, so odds are we can go ahead and round this to 19. And now the question did tell us we're dealing with morphine, so you could actually look up the empirical formula of morphine just to see if this matches, but it looks like the answer is going to be C17, H19, O3N. That looks like it's going to be the answer for the empirical formula of morphine, and since I do have an answer key here, I can tell you for certain it is actually the answer. So this is correct. If you round to only 2 decimal places for these numbers, once you get a bunch of these atoms, anything more than about 10 atoms down there, any rounding you do becomes to start significantly affecting your answers over here. So you're going to have to round your answers a bit more than normal if you round your math as you work the problem. So anyways, that's that. These are the type of problems you guys are doing in your project. The projects are due on Monday, so, I mean, you guys should be able to do this kind of math. You should be all caught up, but we'll kind of see where we're at on Tuesday.